Okay, welcome to Swell Academy. Today we're talking about reflections across Y and X axis, and we're going to go a little bit more detail. In the previous video, we did take a look at, you know, some of the basic rules. No, you don't know. Some of the basic rules, or maybe you do because you watched the video, um, of reflection. But we did look at translation and compression and whatnot as well. But here you have an example where I took a function here, and essentially what we did was I showed the difference of what happens when you put a negative sign outside the function and when you put a negative sign inside the function. So what do I mean? Well, f of x is a function. So if I'm taking the negative of the entire function, or I'm taking the function and I'm making the input, or x, our domain, taking our domain and making it negative, it's going to have an impact two different ways. Here in purple, we see the impact of when we put the negative on the outside. Now you see our original line was this green line here, and when we put the negative on the outside, we see that we had an inversion along the x-axis. You had a reflection along the x-axis, and one of the things that tells us that is that our y values here, our change in y values of a 3 to a -3, that change in y value actually shows us this flip over our x-axis. So when you have a negative on the outside of a function as such, you can put the parentheses there, you can look at it like this, you're going to have a reflection along the x-axis. Now if we look at a graph where we're taking our input, our x, and we're taking the negative or the inverse of our input, you'll see you have a reflection over our y-axis, and you can see that there with the graph here. We're looking at this function where we put the x and negative, and you can see one thing that's a tell, or something that reveals that you had a reflection along the y-axis, is this change actually not in our y-coordinate, but notice there's a change in our x-coordinate, and that change in value shows that there's actually being a flip along the y. That's why you have a change in the x. Now here's a couple examples of some changes. Let's just say you're looking at this and you want to do a reflection along the x-axis. Now remember, you're taking the entire function and you're taking the negative version of that. So in reality, you're distributing this negative sign, negative 10x minus 6. Now with the y-axis, remember, you're changing what the x is going to look like. So you have a 10 plus 6, and we're putting now a negative x on the inside. And that's simply just going to become a negative 10x plus 6. Notice the difference. The difference is kind of in our constant or our y-intercept in our function. But there is a change in signs. Let's look at another example here. Moving along, where we're just looking at a function here. Just let's look at this absolute value. If I'm just changing everything on the outside, right, then ultimately we're not really having an impact on what's going on inside the absolute value function. So you end up with a 4, positive 4. That sign changes. You could keep this the same, minus 4. Now part of what you see when you have the negative on the inside here of this y-axis, you're changing this to a negative x plus 5 plus 4. Now, a lot of what you may see is that this will change this to like a negative 4, you'll see it as a 5 minus x plus 4. But ultimately, we don't want to keep the x negative. So how this will kind of, just watch what happens here. The negative x plus 5 becomes an x minus 5 on the inside. And notice these outside pieces stay the same. So more or less, you're changing what's taking place on the inside of the function, or the inside of your absolute value. And the same goes for the x-axis. Just quick, you don't have to worry about distributing negative signs. You know, with the x-axis, we're focusing on these two outsides, changing that to a plus 7 x minus 8 squared plus 7, where on the y-axis, you're focusing more so on the inside, and that ends up being x plus 8 squared minus 7. So the sign tends to change on the inside of this function here. Something to pay attention to when we're reflecting along the x and y axis. And last but not least, a couple special cases. If you have a negative x on the inside, okay, absolute value negative x is just x. But if you have a negative x on the outside, you would actually just call that a negative absolute value of x. And then if we're looking at the difference between the negative x squared, right? So again, this would be more so towards your y-axis because you're changing the value on the inside. You have negative x times negative x. That ends up being a nx squared. Where if you're just doing on the outside, which is more so your y-axis, you would have negative x times x, which is negative x squared. Same thing here, changing on the inside would be your y-axis, and changing it on the outside would be your x-axis. So here's some, again, special cases, some examples, some idea of what we're doing as far as reflecting and along the x and y axis, and where we're putting the negative sign. Are we changing the entire function, or are we putting the x inside as a change in our input? Like always, the more you fail, the more you succeed. So the focus on it is always on working hard.